Hi, good morning. Right, today is Wednesday, 26th March. Okay, let's look at today's lesson. We are going to discuss about the parallel lines, where you are supposed to find the equation of a parallel line, okay, which is parallel to another line, right? So how is it? Let's look at A and B. A with the equation y equals to 3x plus 5. Now B don't have any equation, but it's stated A and B are parallel. Okay, so if these two lines are parallel, then B's gradient must be same as A's, right? So looking at A, the gradient is 3. So B's gradient is also 3. And it passes through the point 8 and 4. Can we find the equation of B now? Let's look at the solution. Right. Now, since the gradient of B is the same as A, which is 3, and B passes through the point 8, 4, we can work out B's equation. Right. Again, we are going to use the gradient m is equal to 3, the common gradient, and the point which passes through 8 and 4 by substituting into y equals to mx plus c, the general equation. So this is your y, this is your gradient 3, this is your x. We are using this equation to find the c value. So this is 24, this is 4. Bring the 24 over to the left, get a negative 24, so c is negative 20. Now once you get the c negative 20, very simple, we use the y equals to mx plus c, so y becomes, the gradient is 3x minus 20. So very simple, you can get the equation done. Okay, right. Let's look at the next part. Okay, now this one deals with intersection of two lines, right? So how do you find the point of intersection of two lines? There are three ways to do. The first one is to draw both lines on a graph and see where they intersect. That point will be the point of intersection, okay, by using graph method. Or else we use simultaneous equations. The first one, use substitution method, and again simultaneous equation using elimination method. Let's see the graph method. Take a look at the graph method. Okay, right, let's say this is a simple graph. I have two lines here, this line going this way and this line is going this way. They are meeting at this point. Okay, this one with equation y equals to negative 2 over 3x plus 1. This I call tan y equals to negative 14x plus 35. Right, no need to worry about the big numbers or the fraction here. See where they meet, right? So this is 3 and y coordinate is negative 1. So the point of intersection, very simple, 3, negative 1. So the graph method is actually, if you are able to draw the graph out, okay, if the table of values are given for both graph, then you can draw out the graph and see where they intersect and find. Little bit of work because you need to draw the graph, but you can see the point of intersection very clearly. Okay, right. Now without doing the graph, we can also find the point of intersection by using, let's see, the first method, simultaneous equation using substitution method. Okay, I got 3 examples here. The first one is x equals to 3. This one equation, x equals to 3, very simple equation. The second one is 2x plus y equals to 10. Now when the equation is very simple, just take, substitute, right, x equals to 3 into this equation, 2x plus y equals to 10. So x is 3, so you substitute here, so 2 times 3 plus y is 10. So 6 plus y is 10, so y becomes 10 minus 6, which is 4. So the point of intersection is very simple, x is 3, right, y is 4. Very simple, okay. Now let's say substitution becomes little bit more difficult, I would say. So x plus y equals to 1, and here 2x plus y equals to negative 1. Right, there are two equations here. Now remember algebraic formulae, right? Okay, I can make x as the subject here. So I take the first equation, x plus y equals to 1. Now what is x actually? Bring the y over to the right hand side, so x becomes 1 minus y. Now substitute this one, x equals to 1 minus y, into the second equation, 2x plus y equals to negative 1. Can you see that? Right. Now by substituting 2 for x, right, instead of the x here, I'm going to put bracket 1 minus y plus y, this y equals to negative 1. Okay, can you see? Right. Now then, when there's 2 outside the bracket, you must times whatever inside the bracket. So 2 times 1 is 2, 2 times negative y is negative 2y, plus this y equals to negative 1. You simplify this, you get 2 minus 2y plus y is minus y. So 2 minus y equals to negative 1. Bring the number to the right hand side, so positive 2 becomes negative 2. So negative y is negative 3. Negative and negative will cancel each other, so y is equal to 3. Now once you get the y value, what you do, you substitute y equals to 3 into this equation we created, x equals to 1 minus y, right? So in fact, not only this, you can use any one of this equation, you will get the answer. Since x is equal to 1 minus y, so I just put in the y value here. So x equals to 1 minus 3, so x becomes negative 2. So once we get both x and y, then you say point of intersection is actually negative 2, 3. Can you see that? Right? Okay, for this equation, right, these two simultaneous equation, this is the solution. Alright, let's look at the difficult one, the challenging one. Right, I took this challenging one, right? Okay, I'll show you here how to do the substitution if you get something like that. 2x minus 3y is 5, 3x plus 2y is 14. Now solution, choose any equation and you can make x or y as the subject. So you can choose this or choose this, make x or y as your subject. Now let's see. I'm going to choose x as a subject and I'll take the first equation. So 2x minus 3y is 5, right? So 2x, bring the negative 3y over the other side, you get positive 3y. So 2x plus 5 equals to 5 plus 3y. Then what I do, I divide everything by 2 because I can't have the 2 here. So what is x? Algebraic equation, only x or y must be there, right? So x is the subject, so no 2. Bring the 2 here. So x equals to 5 plus 3y divide by 2. Now substitute this x value into the second equation. The second equation is this, right? So the second equation is 3x plus 2y equals 14. Now instead of the x, I'm going to take this value and put it inside the bracket here. 3 bracket 5 plus 3y over 2 close bracket plus 2y equals to 14. Can you see the equation? I replace the x with the y value. Then I multiply the 3 with the numbers on top here. So 3 times 5 is 15. 3 times 3y is 9y over this 2 plus this 2y equals to 14. Now to get rid of this 2, I must times all by 2 here. So to get rid of the divide 2, I times 2 times 2 times 2. So these 2 and these 2 cancel off, giving me 15 plus 9y plus 2 times 2 becomes 4y here. 14 times 2 is 18. So 15 plus 9y and 4y is 13y. I bring the 15 over this side. I get 28 minus 15. So 13y equals to 13. So y becomes 1. Now once you get this value ready, the second part is very easy. You still use, for even though elimination, the second part we use substitution. So substitute y equals to 1 into any of the equation on top. So I am using 2x minus 3y equals to 5. Okay, so the y is 1, right? So put inside here. So 2x minus 3 equals 5. 2x equals to, bring the 3, negative 3 over here. So negative 3 become positive 3 plus 5 gives you 8. So x is equal to 4. So our point of intersection is 4 and 1. You're okay with this, eh? Alright. Now I'm going to show the last part using elimination method. Right. Now I'm choosing the same example previously we used for substitution. Look at the first one. Right, x plus y equals to 1, I call this equation 1. 2x plus y equals to negative 1, right, equation 2. Now can you see this? When the unknown is equal, let's say the y and y equal, I choose that to eliminate because very easy. And both are positive or both are negative. Remember, very careful. Both are positive here or both are negative. I will use negative sign here to eliminate. Remember that, right? So here if I minus this, I get 2 minus 2x is negative x. This will cancel off. 1 minus minus 1 becomes 2. So negative x is 2, so x is negative 2. Now once I get that, I substitute x equals to negative 2 into equation 1. Why 1? I choose the simpler equation, right? So that is x plus y equals to 1. And since x is negative 2, so I put it here, negative 2 plus y is 1, so y becomes 3. Therefore, point of intersection is negative 2, 3. Now, let's look at this one. This is exactly what we did here, right? Can you see that? Under substitution. We took a long while, right? Now, let's look at this, how it works out with the... Now, when you have a difficult equations like this, the best method is elimination. Okay, the first thing you must think carefully. I got 2x and 3x, I got negative 3y and 2y. So the best way is to, you can choose either one, x or y, to eliminate, but you must make them same. Okay, don't worry about the sign, whether negative, positive, what. So I can eliminate x or y here, but I want to choose y because one is negative, one is positive. Easier actually. So how? I'll multiply equation 1 by 2 and equation 2 by 3. Look at this. So the equation 1, when I multiply by 2, everything must multiply by 2. So I get 4x minus 6y equals 10. See, 2x times 2 is 4x, minus 3y times 2 is minus 6y, 5 times 2 is 10. This equation 1 becomes equation 3. Then 3x plus 2y equals 14. I multiply by 3. So 3 times 3 gives me 9x. 2 times 3 gives me 6y. And 14 times 3 is 42. I call this equation 4. I draw a line. Now since I am going to eliminate the y, okay, I am getting here negative 6y and positive 6y. Now when the sign, the unknown I want to eliminate is one is negative and one is positive, always use plus here. Remember, one negative, one positive, you want to eliminate, always use positive. So when I use positive here, 9 plus 3 is 13x. But negative 6y plus 6y becomes 0. And 10 plus 42 gives me 52. Therefore, 13x is 52, x is 52 divided 13, I get 4, right? So, now very easy after that, substitute x equal to 4 into any equation. So, I am choosing equation 2 which is easier. So, equation 2 here, can you see 3x plus 2y is 14. So, 3 instead of x I put 4 plus 2y is 14. So, 12 plus 2y is 14. 2y is 2 because 14 minus 12 is 2, therefore y is 1. Finally, our point of intersection is 4, 1. Can you see? We are getting 4, 1 here by substitution, also 4, 1 here by elimination. But most of you will have difficulty when you do this part. It's a fraction, right? Once you are okay with this, you can still use this. But the easier way, but little bit of thinking, is elimination. You do this, it's very easy, very effective, right? Okay, that's all for today, right? So we will do the work given. You follow the instruction today. Thank you. Bye.